So, to sort of start wrapping up our discussion here on convergence of a series, let me first point out that we covered a few tests for yesterday's set of lectures, and we're going to cover one more test today, which will be very useful for us going forward. But there's several other tests we skipped over, namely the comparison tests, which are quite useful and quite important, quite helpful tools. But we're going to focus on sort of the ones that we need the most here. And really the most important one for us going forward is going to be the ratio test. Right? But let's go ahead and talk about in what ways a series can converge. Right? So all we've talked about so far is, does a series converge or diverge? And, that's important. That's great. There's a special kind of convergence that's sort of stronger than just saying it converges, right? So really, when something converges, there's two ways in which it can happen, right? And these are absolute and conditional convergence, right? So basically, all that means is a series converges absolutely if we can take the series, AK, right, the series in question, and if we put absolute value bars around all the terms we're adding up, then if that new series we made converges by making all of the terms positive, then we say that the series converges absolutely. So we've certainly seen lots of series that converge absolutely, and we've actually even seen some series that converge conditionally. Conditionally means that the series itself that we're interested in does converge. However, the new series that we would make by applying the absolute value to everything doesn't quite converge. So one example of that is the harmonic series, right? The harmonic series, the alternating harmonic series, that converges, but if we apply absolute value to it, it becomes the regular harmonic series, which does not converge. It diverges. So the alternating harmonic series is an example of something that converges conditionally, but not absolutely. So a little theorem here is that if we have a series like this that converges, then this series without the absolute value converges. In other words, if the series converges absolutely, then it converges normally, right? But if it doesn't converge normally, then if the series diverges, we know for sure that the series cannot absolutely converge. Right? Some interesting technical bits there. All right? But again, we'll see that the convergence absolutely sort of says that, the series is a really, really good approximation of stuff that we're going to look at in the future. All right. So let's try and do some examples of figuring out, when does something converge, when does something converge absolutely, and so on. So let's head on over to tablet here. So let's look at whether these series converge, diverge, converge absolutely or conditionally, right? So whether it diverges or converges absolutely or conditionally. That's what we want to figure out. So let's look at this series, k equals 1 to infinity, of -1 to the k plus 1 over square root of k. Right. So let's look at this here. Does this converge conditionally? Does this converge absolutely? Does it diverge? Let's find out. Right. So if we're going to sort of check this, we may as well start by checking for absolute convergence. Because if it converges absolutely, it automatically converges conditionally. Right? So let's check for absolute convergence. All right. So we're going to write this sum, 1 to infinity, and we're going to apply absolute value to everything. Okay. So k equals 1 to infinity. This is now just 1 over square root of k. All right, so the question is, does this converge or not? Well, the way we can figure this out is, hopefully you can recognize this as a type of series we've already talked about. Right? If we rewrite this using an exponent for the k in the bottom, this is a p series with p equals 1/2. Right? So what does that mean? Does that mean it converges or diverges? Well, you might remember, since here p is less than 1, or less than or equal to 1, come on, this means diverges. Right? So it does not converge absolutely. It doesn't converge absolutely. Right? That doesn't happen. But might it still converge conditionally? Right? So how do we check that? Well, look at what kind of series this is. Right? So I'm going to write here conditionally convergent. So let's look at the kind of series we have here. This here is an alternating series. Right? We have an alternating series here. So the question is, well, does that converge? Right? So we're going to try and apply the alternating series test to it. Right? So here, as far as the alternating series test is concerned, this AK is 1 over square root of k. Remember, an alternating series is one that looks like this. Right? So there's a couple things we have to test. Right? The first thing is, the first thing is actually 2 parts. So one, we want to know, are the terms decreasing? In other words, do we have this? Is this true? Well, the good news is AK is in fact greater than 0. All these terms are in fact positive. So we don't have anything to worry about there. Okay? So now we need to check this part. So 1 over square root of k, we want to know, is this in fact less than or equal to 1 over square root of k plus 1? I've written this the wrong way. Sorry. They need to be decreasing. Just realized I wrote that the wrong way. All right. Sorry. Let me fix that. So what we want to know, is this a true statement? Right. Well, again, we'll do the cross multiplying trick here to put everything on one line, and that's square root of k less than or equal to square root of k plus 1. And that's true. Right? So it passes the first test. Right? The second test is the limit of the AK's 0. Right? That's the second test. So go ahead and take this limit here, 1 over square root of k. Right? Probably no surprise this is in fact 0, as we want. So this series here, this converges by, I'm just going to call it the AST for alternating series test. All right. So overall, we can say since the series converges but does not converge absolutely, we say the series converges conditionally. Right? And that's the answer we're looking for here. So hopefully that makes sense. Let's go ahead and look at another example here. It's going to be a similar example, this one to the k, over square root of k cubed. All right. So what's going on here? Well, let's check again. The first thing we should do is say, does this converge conditionally? Right? Unless it's sort of obvious that the series is going to diverge or something like that, it's a good idea to check for absolute convergence first. So, all right. So what we want to know is, does this absolutely converge? So, apply the absolute value bar to this. Right? And basically all this absolute value is going to do here is, in this problem here, is just going to get rid of that -1 to the k. Right? So, again, if we rearrange this as a p series, we see k to the 3/2. Now here, this is also a p series. And here, p, which is 3/2, is greater than 1. So this means convergent. So since this series that we have here converges, that means our original series converges absolutely. All right? So this series converges absolutely. All right. And that's great. All right. I want to wrap this up with one more example. All right. Let's look at this series here. All right. So -1 to the k cubed over k cubed plus 4. Right? If we look at this example here, what do you think? Is this going to converge? Is it going to diverge? If it converges, is it absolute or conditional? Remember, the first test, the easiest test to apply is the divergence test. Right? If we look at this right here, the limit of this thing is not 0. So, that's always a good thing to keep an eye out for. If you just give your terms, just give it a glance. If the limit of that's not 0, you're pretty hopeless, right? Because if this limit's not 0, the series is going to diverge, so it can't converge conditionally or absolutely, right? So here what we're going to say is, well, the limit as k goes to infinity of this thing here, this has to diverge. This limit diverges, this limit doesn't exist, because even if we did the limit without the alternating sign, this equals 1. So this sequence here is bouncing back and forth essentially between 1 and -1 as when k gets really, really large. Right? So this diverges, so this diverges by a divergence test. Right? All right. So this is what I mean when I say sort of keep an eye out. Like if it looks like it's going to diverge, you might want to check for that before trying to do anything else. Right? So we'll do the next video here on the ratio test, and then keep it simple, keep it at that for today.